Okay, this is ELEC1 2019 question 6. Part A. The diagram shows a binary encoded disk. As it rotates, the reflective opto-switches output signals which can be used to determine the position of the disk. Over white, an opto-switch outputs a logic 0 signal. Over black, it outputs logic 1. We have a diagram with a disk and 4 diameters. We've got the reflective opto switches, and it says what problem can occur as the binary disk, and that's key that it's a binary disk, rotates, moving the opto switches from segment X to segment Y. In your answer, explain the cause of this problem. Well, the main problem with binary disks is that the binary encoded disk can suffer from false readings. So, binary disk can suffer from false readings. And the reason for this is as the disk rotates, what happens is that the inner switches can be triggered before the outer switches. Okay, triggered before outer switches. Now, it's probably a good case to give an example as far as this is concerned. So ideally, if you're going from X to Y, what you get is 1, 0, 0, 0, which is what X is. And remember, you've got to read from the inside out in terms of the binary value. And you want it to go to Y's value, which is 0, 1, 1, 1. But in reality, what you get is 1, 0, 0, 0 going to 0, 0, 0, 0 because the inner ring will switch first, and then you get 0, 1, 0, 0, and then you get 0, 1, 1, 0, and then you get 0, 1, 1, 1. And so you can see you get a whole host of false readings, and in this example, these 3 in the middle are the false readings that we'd be worried about. Okay, B part 1. Why is this not a problem with a grey encoded disk? Now, it's very easy not to give enough information as far as this is concerned. And if you read the examiner's report, lots of students just give part of the answer and didn't get the mark. And the part of the answer they gave was only 1 bit changes at a time. But that doesn't give the context over 1 bit changing at a time. And what you need to do is to include from adjacent segments as the disk rotates. And that really means that only 1 bit changes from each segment side by side as the disk rotates, so you never get multiple changes as you go from one to the next. Okay, so B part 2. Now, this is a classic grey code type question. We have a picture and it says complete the outer ring of the grey code disk by shading in the appropriate areas. Now, this is classically done very, very poorly by students, and because they don't know where to start and they don't know what the pattern is. And I was fortunate enough to be teaching students a few years ago, and one of the students said, wait there, if we draw a table, is there a clear pattern? And we drew a table, and if you look at this particular table where D represents the inner disk and A represents the outer disk, hopefully you can see there's a very, very clear pattern. in terms of the frequency of the zeros and the ones as you go from the number 0 down to number 15 in this particular example. And you can do this for any number of rings on your grey coded disk. Now, hopefully what you can see is we can figure out hopefully where the 0, 0, 0, 0 is. And what we find when we actually do this is it's this particular segment here, which must be 0, 0, 0, 0. And then this next segment is 1, 0, 0, 0. Because remember, that we're going from A, B, C, D, but really it's D in the center. So if it was binary, it'd be 0, 0, 0, 1. So if we shade this segment, remember this segment here is A. Then we can follow around, and because the pattern is 0, 2 1s, 2 0s, 2 1s, 2 0s, 2 1s, 2 0s, 2 1s, and then the final 0, it's quite quick to actually then start to shade in all the segments that we need to shade in order to get the full marks. And considering this is worth 3 marks, it's quite an easy question to get the marks on if you know the pattern. As I said, the table is probably the key as far as this is concerned. Okay, on to question C. Now this was done very well by students nationally. So let's have a look at this. So it says an amateur yachtsman designs an electronic system to display the wind direction. A wind vane moves an arm holding 3 opto switches P, Q and R, and a 3-ring grey encoded disk. Over white, an opto switch outputs a logic 0 signal. Over black, it outputs logic 1. And we've got our disk here, and we can see that the opto switches are pointing north to begin with. It says the outputs of P, Q and R are processed to light the appropriate LED on the display shown in the following diagram. And as you can see there, we've got our north, south, east and west. And the question basically asks that the outputs are used to address appropriate memory locations in a small memory IC. The table shows the contents of the memory. For example, when the outputs are P equals 0, Q equals 0 and R equals 0, memory location 0, 0, 0 is activated. The output of that location is used to light LED, N LED, or the north LED. And then we've got our table. You can see that the first line is filled in. And it says complete the table by adding the names of the LEDs lit by the contents of the other memory locations. Now the key to this is to remember that R is the most significant bit and it's the inner ring. And therefore, when we're reading across here, we've got to make the disk correspond to the table. So we already know that in our table that the first line, 0, 0, 0, is north. So what's the next one? Well, for the next one, R is going to be 0, Q is going to be 0, and P is going to be 1. So we're looking for, in the table, a 1, a 0, and a 0 going from left to right. So down here is going to be northeast. If we want to look for the P0, Q0, R1, then what we've got to look for is P being a 1, so R being a 1, so high, and we're going to have 0, 0, so that's northwest. And the rest of these, hopefully, are pretty straightforward. So this is southeast, this is south, this is west, this is east, and this is southwest. Okay, part 2. How many different wind directions could be sensed using a 5-ring grey encoded disc? Well, if we look back at the disc, hopefully what you can see, if we look back at the very original disc that we had in the first part of the question, what we can see is that as we go outwards, there is theoretically the chance of more information. And so if we just had a single disc in the middle, you could have maybe just 2 choices. One, go to 2 discs and you could get 4 choices. Go to 3 discs and you get 8 choices. So every disc that you go out, you double the amount of information that you can glean. Another way of putting that is that the amount of information you get from these discs is 2 to the power of the number of discs. So because we've got a 5-ring grey encoded disc that we're looking for, we can look at 2 to the power of 5, and 2 to the power of 5 is 32. So we're looking at 32 directions. And there concludes the end of question 6.